everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about problems on test of hypothesis for single mean and test of hypothesis for difference of means. Test of hypothesis for large samples. In test of hypothesis for large samples, we have 4 tests. First one is test of hypothesis for single mean, and second one is test of hypothesis for difference of means. Third one is test of hypothesis for single proportion, and fourth one is test of hypothesis for difference of proportions. Now, coming to the first method, test of hypothesis for single mean. Consider a sample of size n, small n, with mean x bar from the population with mean mu and standard deviation sigma. Then the test statistic z is given by z equal to x bar minus mu divided by sigma by root n. Okay, so here the confidence interval for single mean. The confidence interval for test of hypothesis for single mean is x bar equal to, confidence interval is x bar equal to, confidence interval equal to x bar minus z alpha into sigma by root n, comma x bar plus z alpha into sigma by root n, or we can write x bar plus or minus z alpha into sigma by root n. X bar into x bar plus or minus z alpha into sigma by root n. Instead of sigma, sometimes we can use s also. First problem. The mean of random sample is 11,795 and standard deviation is 14,054. If sample size is 50, find 95% confidence interval for the mean. So, in our question, they have given that mean of the random sample. Mean of the sample is denoted with x bar and standard deviation of the sample is denoted with s. Okay, the sample size is denoted with small n. Find the 95% confidence interval for the mean. Okay, so just here we need to find the confidence interval. So before that we need to learn what is population and what is sample. So population size is denoted with capital N and sample size is denoted with small n. Okay, so population mean is denoted with mu and sample mean is denoted with x bar. Population variance is denoted with sigma square and the sample variance is denoted with s. So population s square. So population standard deviation is denoted with sigma and the sample standard deviation is denoted with s. So first of all, we need to remember these points. Okay, so before going to start or before going to solve the problem, first of all, we need to remember these points. Okay, so in our question, they have mentioned that sample mean of the sample, that is denoted with x bar, and sample standard deviation. That continuation is there, no? So that's why that is sample standard deviation, that is denoted with s, and sample size is denoted with n. Okay, so here x bar value is 11,795 and s value is 14,054 and n value is 50. Okay, so z alpha value. So what is z alpha value? So at 95%, means here we have to take alpha is 0.05 or 95. Okay, 0.95 or 5% are same, and z alpha will be 1.96. Okay, so here Z alpha will be 1.96. So here we need to find the confidence interval for mean. So the confidence interval for single mean is x bar equal to, confidence interval for single mean is x bar minus Z alpha into sigma by root n, comma x bar plus Z alpha into sigma by root n. Okay, so that is equal to x bar minus Z alpha into sigma r s by root n. Okay, so here we have s now, that's why we need to write s. So x bar plus Z alpha into s by root n, right? So x bar value is 11,795 minus what about Z alpha? Z alpha value is 1.96. Here the Z alpha value is 1.96 and S value. So what is S value? S value is 14,054. 14,054 divided by root 50. Okay, so like that x bar is 11,795 plus Z alpha value is 1.96 and S value is 14,054 divided by under root of 50. Okay, under root of n is root of 50. So after simplification, we will get 7,899.43, comma 15,690.57. So this is our confidence interval. So next, coming to the next method, test of hypothesis for difference of means. Let x1 bar be the mean of the sample size n1 from the population with mean mu1 and standard deviation is sigma 1, and x2 bar be the mean of the sample of size n2 from the population with mean mu2 and standard deviation is sigma 2. Then the test statistic z equal to x minus x bar divided by x1 bar minus x2 bar divided by and a root of sigma 1 square by n1 plus sigma 2 square by n2. Okay, so note, if sigma 1 and sigma 2 are not given, then we can use S1 and S2. In that case, Z equal to x1 bar minus x2 bar divided by under root of S1 square by n1 plus S2 square by n2. If samples are not drawn from the same population, so in that case, samples are drawn from the same population. Samples are drawn from the same population is sigma 1 equal to sigma 2 equal to sigma, that is equal to, instead of sigma 1 sigma 2 we need to put sigma, that is equal to z equal to x1 bar minus x2 bar divided by under root of sigma square by n1 plus sigma square by n2, or we can write x1 bar minus x2 bar divided by sigma into under root of 1 by n1 plus 1 by n2. So coming to the first problem, a sample of students drawn from two universities, their mean and standard deviations are calculated and shown below. Test the significance difference between two means. So University A mean is 56 and University B mean is 57. University A standard deviation is 10, University B standard deviation is 15. University A sample size is 400, University B sample size is 100. So that means here sample size is, we know that sample size is denoted with n1 and sample, this is n2. Sample size is denoted with n. Here we have two sample sizes. That's why n1 equal to 400 and n2 equal to 100. And sample means are denoted with x bar. So x1, here we have two sample means. So that's why x1 bar equal to 52, x2 bar equal to 57. And standard deviations are denoted with s. That's why s1 equal to 10 and s2 equal to 15. Okay, so alpha, here we have to assume that alpha value. So alpha equal to 5%. So null hypothesis is x1 bar equal to x2 bar and alternative hypothesis is x1 bar not equal to x2 bar. Then the level of significance. That means the samples are, the level of significance alpha equal to 0.5. Here I am assuming that alpha is 5% or 0.05. So Z alpha will be 1.96. Test statistic. So the formula is test statistic Z equal to x1 bar minus x2 bar divided by under root of s1 square by n1 plus s2 square by n2. So x1 bar is 56. So we know that x1 bar is 56 and x2 bar is 57. S1 is 10, s2 is 15, n1 is 400, n2 is 100. Okay. So substitute all these values here. 56 minus 57 divided by 10 square by 400 plus 15 square by 100. So after simplification, we will get 0.632. So then we need to take modulus of z, that will be 0.632. So the conclusion is here modulus of z less than z alpha. Because the modulus of z value is 0.632 and the z alpha value is 1.96. This is 1.96. So always 0.632 is less than 1.96. That's why, therefore, modulus of z less than z alpha. So therefore, we accept null hypothesis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.